Good morning, ma'am. My name is Triyari. I am from Computer Science Engineering Department, CSC F section. Today, my topic is Clausius-Massotti equation. Introduction to the Clausius-Massotti equation. The Clausius-Massotti equation relates the dielectric constant of a material to its molecular polarizability. This equation is crucial for understanding how materials respond to electric fields. It finds applications in various fields, including material science and electrical engineering. Historical background. This Clausius-Massotti equation was developed in the 19th century by physicians Claudio F. Clausius and Ottavino Massotti. It was formulated to explain the behavior of dielectrics in the presence of electric field. The equation has since been fundamental in the study of dielectric materials and their properties. Clausius-Massotti equation. The relation between dielectric constant E mu r and polarizability alpha is called Clausius-Massotti equation. When a dielectric placed in an electric field, it undergoes polarization. The spectra the separation of charge carriers includes the separation of charge carriers induce dipole moment which is directly proportional to local field. Where in mu is proportional to EL, where mu is equals to alpha EL. That is the equation 1, where alpha is polarizability. We have P is equals to N into mu. Substitute equation 1 in equation 2, where P is equals to N alpha EL. We have EL is equals to E plus P by 3 epsilon naught. It is the fourth equation. Substitute equation 4 in 3, where P is equals to N alpha E plus P by 3 epsilon naught. N alpha E plus N alpha P by 3 epsilon naught. P minus N alpha P by 3 epsilon naught is equals to N alpha E. P 1 minus N alpha by 3 epsilon naught is equals to N alpha E. P is equals to N alpha E 1 minus N alpha by 3 epsilon naught. It is the equation 5. We have P is equals to epsilon naught at the bracket ER minus 1. It is the sixth equation. We can see in the side D is equals to epsilon naught plus P. D is equals to epsilon E, where epsilon R E R epsilon by epsilon naught is equals to epsilon R epsilon naught. D is equals to epsilon R epsilon naught E, where P is equals to epsilon R epsilon naught E minus epsilon R epsilon naught E. That is the final equation. P is equals to E epsilon naught E ER minus 1. We are equating this 5 and 6th. Epsilon naught E ER minus 1 is equals to N alpha E by 1 minus N alpha by 3 epsilon naught. Here epsilon R minus 1 is equals to N alpha by 1 minus N alpha by 3 epsilon naught. 1 minus n alpha by 3 epsilon naught is equals to n alpha by epsilon naught epsilon r minus 1. 1 minus n alpha by epsilon naught epsilon r whole to the power of minus 1 plus n alpha by 3 epsilon naught. 1 is equals to n alpha by 3 epsilon naught, open the bracket, 3 by epsilon r minus 1 plus 1. 1 is equals to n alpha by 3 epsilon naught, 3 plus epsilon r whole to the power of minus 1 by epsilon r whole to the power of minus 1, where the final equation is n alpha by 3 epsilon naught is equals to epsilon r minus 1 epsilon r plus 2. This is the Clausius-Massotti equation, where the Clausius-Massotti equation is n alpha by 3 epsilon naught is equals to epsilon r minus 1 by epsilon r plus 2. Applications in material science. The equation is widely used in the characterization of polymers, ceramics, and composites. It helps in understanding how these materials behave under electrical stress. The Clausius-Massotti equation also aids in development of advanced materials, capacitors, and insulators. Limitations of the Clausius-Massotti equation. The applications. The equation assumes a uniform field and does not account in homogeneities in the material. It is primarily applicable the non-polar materials, limiting its use the polar substances. Experimental conditions such as frequency, temperature, effect, accuracy, predictions made by the equation. Conclusion. The Clausius-Massotti equations remains a cornerstone in the study of dielectric materials. Its ability to contain microscopic properties with microscopic behavior is inevitable. Future research will continue to enhance its applicability, especially in emerging technologies. Thank you, ma'am, for giving this opportunity.